just want to give you a quick introduction. Talk about HiCounselor program. So at HiCounselor, we help everybody, whether that's mentorship, whether that's for helping you with technical coding questions, whether that's for how to talk to recruiters, and whether that's for talking to interviewer, and how to effectively communicate your skill sets to them so that you place yourself in an optimal position so that you have higher likelihood of achieving that position. So at HiCounselor, we help with all of that. And I personally help with those things: interview, mentorship, coaching, as well as the recruiter call and the interview call. So at the front, there's no upfront cost. You pay $0. You only have to pay only if you get job yourself, at which point we'll take away some of the money then. So there's zero upfront cost. Everything is absolutely free until you get the actual job. So make sure you go to hicounselor.com, as you can see in the link, and use the code referral. Use the referral code called Andrew. That is ANDREW. That's the referral code on HiCounselor. Okay, so let's kick off this session. So my recommendation for my tutorials and my lessons is that everybody writes down the questions, my lessons, tutorials, and answers in pen and paper. That's the way I learned it, the technical questions, while I was back in Waterloo, which is the engineering school. And I've always had twice as better learning experience when I actually write the coding questions, write it down, and because that makes you think and really grab that input into your brain if you write it down on a piece of paper and pen. So just watching me and just typing what I do, it's not very helpful, because that's going to minimize your brain absorbing process. Okay, so I highly recommend that you write it down in your pen and paper. Okay, so the question I want to ask you is, and we're gonna solve together, is like, you are a lead. Let's say you're a team lead, launching a brand new product, and very unfortunately, the latest version of your project fails that quality check. Okay. And because every version is developed on the basis of the previous version, all the versions after a bad version is also going to be bad, right? That just makes sense. So suppose you have some n number of versions, like 1, 2, 3, 4, 5, 6, 7, all the way to n, and you desire to find what's the first bad version, which causes all the following versions to be malicious or bad. And you're going to be given a method called bad version, which returns Boolean value of whether the version is bad or good. So we want to basically make a method which locates the first bad version effectively. And we ideally want to minimize the number of method calls to the method called bad version. Okay, so what is the example? Let's say you have n equals to 5. Let's say you have bad equals to 4. Then what should the outcome be, right? Well, let's do some steps. Let's say we call bad version, which is a Boolean. That's going to give you false, right? Let's say you do call bad version. That's going to give you true. Let's say you call bad version 4. That's going to be true. So we know that the 4 version is the first bad version. Okay. That's our goal. How about second case where n equals 1 and bad equals 1? We know that output is going to be 1. Okay, so this output is going to be 4, this output is going to be 1. So let's discuss this more. What is a very, effective, simple solution that will compute our algorithm? There's a couple ways. Number one, it looks very simple, but it could get a little tricky. So the first algorithm is, the bad version method is defined in the parent class, right? Let's say we assume that. So our solution is going to extend that parent class, and our method is going to be called, let's say, first bad version. Okay. So what we can do is we calculate the mid value, and then we actually find that first bad version by comparing the left and right pointer and using the mid value of that, and then calling that bad version. And if that's not so if it's the bad version, then we're going to record the mid value as the current answer. And then we're going to say that the right pointer is going to be one left to that. Okay. So again, if we find some mid value that is a bad version, right, then the answer is going to be the mid version, but we're going to say that the right pointer is one left of the mid value. So we're sort of like decreasing the window one by one. Now, if the mid value is not a bad version, if it's a good version, right, now we're going to say that the left pointer is equal to mid plus 1. So we increment mid to the right one side. Okay, so let's write this down. How would we put this into code? So let's say we have a solution that extends, let's say we have parent, like I'm just gonna name it, let's say version. Okay, and then we're gonna have a method called first version. So left is going to be set to 1. Right is going to be set to 1. Right is going to be set to n. And then answer is going to be initialized to -1. So we're going to do a while loop, right? As long as left is less than right, or left is less than or equal to right, we're going to say, okay, middle value is going to be left, because left plus right minus left divided by 2, because remember, this is the formula for calculating the middle value. Okay, so if you wanted to avoid an overflow in case, then we make sure that left plus right is equal to 2147 483647, which is the the overflow threshold. Now, so remember, we checked for a couple things. If this mid value is a bad version, right? So remember, the bad version, we are provided with API called bad version. So if it's a bad version, then we'd say answer is going to be equal to mid, and right is going to be middle -1. Okay. we're going to record the middle as the current answer. And then we're going to try to find smaller version in the left side. Okay. Now, let's say mid value is not, let's say it's a good value, right? And we have to increment the left counter to the right side to find the value in the right side. Okay, so this is a very intuitive solution using pointers. So this makes sense because we are calculating the right, left, and right. Okay, let's do another question. Let's say you're given a number and you want to find and return an array answer that's going to be of length n+1. And the only requirement is that for each I where 0, by the way, this is a different question. We're doing another question. For each I that's between 0 between 0 and n, the answer I is equal to the number of ones in the binary representation of I. Okay, so we're given a number. We're going to find and return an answer. We're going to find and return an array called answer of length n+1, such that for every I between 0 and n, answer at I index is the number of ones in the binary representation of I. Okay, so let's give you an example. If I give you an example, it will look something like this. Input, let's say we have n equals to 2. Let's say output, we have 0, 1, and 1. And the explanation is that for 0, the corresponding value is going to be 0. For 1, the corresponding value is going to be 1. For 2, the corresponding value is going to be 1, 0, because it's the binary representation of these numbers. Let's say you have input, let's n equals to 5, output equal to 0, 1, 1, 2, 1, 2. And the output is going to be 0, 1, 1, 2, 1, 2, because 0 corresponds to 0, 1 corresponds to 1, 2 corresponds to 1, 0, 3 corresponds to 1, 1, and 4 represents the 1, 0, 0, and 5 represents the 1, 0, 1. Okay, so this is the way we're going to formulate the question. We're going to take an input of n, and we're going to produce an array of answer of length n+1 in such a way. So what are some of the ways we can solve this? Well, we have a couple of ways again. We can use the actual problem description, which is the ranges. Essentially, the numbers in one range are equal to 1 plus all of the numbers in the ranges before. Let me repeat that. The numbers in one range are equal to 1 plus all the numbers in the ranges before that. So if you write out the binary numbers, you could see that the integers from 8 to 15 have the same pattern as 0 to 7, but with that 1 at the front. So you can see that 8 to 15 have the same pattern as 0 to 7, but with a 1 at the front. So we can use this problem description and the description pattern to find out the answer. So what is going to be our logic? Okay, what is going to be our logic? Our logic is going to be to copy the previous value starting at 0 until a power of 2 is hit, the new range. And at that stage, we reset the we reset the pointer back to 0 to begin the new range. Let me repeat that. Our solution is going to basically copy the previous value starting at 0 until a power of 2 is hit, the new range. And at that phase, we reset the pointer back all the way to 0 to begin a new range. Okay, so how does this look like in the code? So for new people joining in, we're doing a series of actual coding interview questions that I faced while interviewing for companies like Microsoft, Amazon, Stripe, and even more. And make sure you go to HiCounselor.com and use the referral code Andrew, because I'm going to be giving you all the mentorships, coaching, and technical questions that I actually used for these coding. So let's continue. We're going to have answer as a array of integers, and then we're going to first set the first value of answer array to 0. So we're going to initialize the number of the variable power. And for int equals to 1 and t equals to 0. So this is going to be our initial value. Okay. All the way to number. We're going to increment the I as well as t. So the power is going to be times 2, because remember we performed the copying of previous values starting at 0 until a power of 2 was hit. So power is going to be multiplied by 2, and t is going to be equal to 0. So once we're out of this for loop, so what does this for loop do? It will go from all the way to I equals 1, and from t equals 0, and then for all the values up to number, we're going to increment I and t one by one. Oh, and more importantly, if I is equal to power, right? That's when we multiply power by 2 and set the t back to 0 all again. Okay, so if I, which is the current value, is equal to the power, whatever that's going to be, 1, 2, 4, 8, whatever that's going to be. If I is equal to that power, we're going to say power is times 2 on that, and then we're going to reset t all the way to 0 again. So here at the end of the for loop, we have to update it. We have to update the answer array. So we know that the answer at the ith index is going to be answer at t plus 1. And then we're going to return answer. Okay, so let's review this. We basically leveraged the problem description, which is the ranges. So the numbers in one range are equal to 1 plus, right? 1 plus all of the numbers in ranges before that. So if you actually, jot down the binary numbers, we know that the integers from 8 to 15 have the same patterns as 0 to 7, but with the 1 at the front. So what did we do? We basically copied the previous value starting at 0 until a power of 2 was hit, which is a new range. And at that point, we resetted the t pointer back to 0 as here to begin a new range. Okay, so this is the idea. Another way to do this is without a t variable, it might be slower, but more concise. So you can do this actually without a t variable. So this is my home, not a homework, but something to think about for you guys, which is that try doing this without the variable t. It might be slower, but it's going to be more concise. And the solution of this problem is going to be sort of like the gray code. Okay, so what is another good question? Let's say let's do another question. Let's say given an integer n, our goal is to return true. Basically, we say yes, and if that's the power of 4. It's a very simple question, but there's many ways to solve this. Given an integer, we want to return true if that's the power of 4. Of course, return false if it's not. And another hint is that an integer n is the power of 4 if there exists a number x such that n is equal to 4 to the power of x. Okay, so let's do example. N equals 16. That's going to be true. N equals to 5. That's going to be false. That's not a power of 4. N equals to 1. Output is true. So what is some optimal ways we can solve this? What is a simple, or even better, what is a simple solution we can tackle this? Well, we can use the bits. We can use the zeros. We can use a modulo operation. We can use a power of 2 and 4. There's many ways. And again, this is another way I would like you to solve this, different ways. Now for, the way I solve this is very intuitive, which is that I divide this into 3 sections. Number 1, if the number is less than 0. If the number is a modulo, the number's modulo of 3 is equal to 1, meaning that the remainder of dividing by 3 is equal to 1. In that case, it's going to be very simple code. Another, I think, really effective way is that we have, all the 0 bits and a 1 minus 1 bits, and zeros after 1 should be even. So 1 0 means multiple of 2, and 2 0 means multiple of 4. So we can use that property as well. Another way is a recursive solution where we recursively call this problem. So we take number of x. Let's say we do example. Let's say we have take number X as an example. Let's say 100111001, right? So we're going to divide that into two parts. Number one, the last digit, 1 or 0, which is equal, which is the same as I modulo 2. So what is the second part? The other digits, the number of 1, which is equivalent to f and I divided by 2. Okay. So to explain this, when it comes to even numbers, like 2, 4, 6, 8, the binary numbers should be like 10, 100, 110, 1000. So one big difference is that their unit digit is always 0, right? So that indicates when you call, so when you call shift 1 bit rightwards, that also means dividing by 2 would cause no change to the count of 1 in the binary string. So vice versa, when you meet odd numbers, shifting 1 bit rightwards always eliminates one digit from the original binary string. This is why we sort of compensate the 1 character to the count. So to summary, when you meet even the count of 1s is always the same as its half number. On the other hand, we have to plus 1 to the odd's half number. Okay, so this is the way I solve it. And take this home, try it out in your by yourself, and test it out. Run this code and try it out. By the way, I'm doing another solution for counting the bits. Sorry for the confusion. Before I move on to the next question, which I already described, I wanted to give you another solution to this for counting the bits. Okay, so same argument, int function is going to be new int 1. So for int I, all the way to end of the range, we say function at I is equal to function I1 plus I-1. Okay, and the return function. So this might seem a little bit, new to you, but try it out. Basically, we when it comes to even numbers, we know that it's going to be, for even, it's going to be 100110. The representation will be 1000. So the notable difference is that their unit is always 0, right? Like as such, which means that when you call this, right, shift 1 bit rightwards also means dividing by 2. It would cause no change to the count of 1 in the binary string, right? Like this. That's the whole point. We're using that property. Vice versa, when you meet an odd number, shifting 1 right always eliminates 1 from the original binary string. That's why we compensate the one character to the count. Okay, so let's go back to the power of 4. What's a good way to get the power of 4? The one way I approach this is it's easy to find that power of 4 numbers have those 3 common features. First, greater than 0. Second, only have single 1 bit in their binary notation. So we use this property. Again, only have a single 1 bit in their binary representation. So we're going to use x minus 1 to delete the lowest one. And then if then it becomes 0, it proves that there is only one single 1 bit. And thirdly, the only 1 bit should be located at the odd location. For example, 16. The 16's binary representation is 0001, 0000. So we can use 0, x 55, 55, 5555 to check the 1 bit is in the right place. With this process, we can actually code it out very, concisely. So this might be a little bit, non-intuitive. So what is another good way? Another good way for the ease of understanding is we use logarithmics, right? We can use a log, easy solution, no loop, no recursion. Basically says that if the number is less than 0, we return false. And then we say the log value, which is going to be log of the number divided by math.log at 4. So this is a basic, mathematics. This is the way we solve the logarithmics and find the power of 4. This is the property of logarithmics. So we're just using the fundamental properties of logarithmics to code this out. So we're going to return log modulo 1 is equal to 0. So how do we make this into code? Let's try it out. So the question is, if it's a power of 4, if the number is power of 4, this is the solution we're trying to optimize for. If the number is less than 0, the base condition, return false. Okay, so very simple. We basically did, if the number is less than 0, we return false. We determined the logarithmic value, which is the math log of the number divided by log of 4. The fundamental properties of logarithms. And we return logarithmic modulo 1, with the remainder of divided by 1. And if that is 0, if there's no remainder, we know that that's power of 4. Okay, so I want to present you a very interesting solution, interesting question I also faced while interviewing for the big tech companies. it is that we want to basically find and write an algorithm to determine if the number n is actually sort of fits the requirements. And the requirement is that it has to be a number, and the number defined by these processes. Number one, starting with any positive integer, we replace the number by the sum of the squares of its digits. So the first requirement is that we're starting with any positive integers, replace the number by the sum of the squares of its digits. Second requirement, we repeat the process until the number equals 1, where it will stay, or it loops endlessly in a cycle which doesn't include 1. So what is the last process? The last requirement is that those numbers for which this process ends in 1 is equal to satisfactory. So this is when the requirement is fully met. So we were going to return true if that n meets the criteria, and false if it doesn't. Okay. So let's give you an example. Let me give you an example of this. Let's say we have input equals to 19. What is going to be the output? Okay. I want you to think about it. What is going to be the output if the input is 19? Well, let's try it out. So we know that 1 to the power of 2 plus 9 to the power of 2 is going to be 82. Right? We know that 8 to the power of 2 plus 2 to the power of 2 is going to be 68. We know that 6 to the power of 2 plus 8 to the power of 2 is going to be 100. We know that I to the power of 2 plus 0 to the power of 2 is plus 0 to the power of 2 is equal to 1. So output is true, right? Because we started with a positive integer. We replaced the number by the sum of the square of its digits, remember? And then we repeated this process until the number equaled 1, where it should stay, or it loops endlessly in a cycle, which doesn't include 1. So those numbers for which this process ends in 1 is satisfactory number. So this is the requirement for our algorithm. So we're going to say return true if that's a satisfactory number, and false if it's not. So I'll give you, just 60 seconds to think about the solution. I'll give you 60 seconds to think about, well, what is the number one, optimal way, number two, intuitive way to solve this, which is that we want to find a satisfactory number that fits this requirement. So I'll give you 60 seconds to think about it, because if you actually think before, then my solution is going to be more absorbing and be more effective for learning. Okay, so we're back. So a good, well, I mean, a very intuitive solution is to use a data structure hash set to, there's many ways, by the way, there's many ways to solve this, but one good way is to use a data structure called hash set to record the sum of every digit square of every number that's faced, okay? So once the current sum can't be added to the set, we're gonna return false. And once the current sum equals 1, we return true. Okay, so once again, we use the hash set structure and we record the sum of every digit integer of every number occurred. And when the current sum can't be added to the set, we return false. And once the current sum equals to 1, which is our description here, we return true. So let's write this down. How does this look like in a code? So we're going to say a hash set of integer is going to be in loop. Okay, we're going to say the variable is called in loop. Or even better, loop set. Okay? Even better. We're going to declare two variables, remainder and squares. So we're going to check a couple of things in the while loop. Number one, well, n is larger than 0. So within that while loop, yeah, we're going to check for a couple of things. While n is larger than 0, which is a number. And then sum of squares is equal to 1. Else. And then false. Okay, so I want to set this as to do. Okay, I want to set this at to do, and what I want you to do is I provided the skeleton code for this code. I want you to think about what should go inside here, right? We basically laid out an outer while loop that contains, mostly 3 parts. Number one, another while loop that runs as long as number is equal to 0. If statement, which checks the sum of squares is equal to 1, and else, where number of squares is not equal to 1. Okay, so what should be inside these to-do blocks? I'll give you 60 seconds to think about it. Try it out. It's going to be very, very helpful if you think beforehand, and I write my solution. Okay, so the solution here is that we have to essentially, within the while loop, we want to add number. We want to add that number to the loop set, right? So to the loop set, we're going to add the number. So while, we keep adding the number to the loop set, essentially what we're going to do is run these inner code as long as we can add that number and actually operate the addition of that number to the loop set. And then we're going to run these inner code. Okay, so every iteration of the outer while loop, we're going to add the number, which, by the way, can be updated internally to the loop set. Okay, so within that outer while loop, we're going to reset the sum of squares to be 0. And while the number is larger than 0, we're going to say that the remainder is n divided by 10's remainder, n modulo 10. And then we're going to say sum of squares is equal to the sum of squares plus remainder times remainder, which, by the way, can be written as right. And then we're going to divide the number by 10, right? We've done all the operations needed, so we can now reduce that number by dividing by 10, so that we move from, let's say, this to this, okay? From this to this, for example. Okay, so what should go inside here? So what should go inside this if statement? Number of squares equal to 1. Well, we know that the sum of squares is equal to 1 has been met, so we simply return true, right? Because we've done all the operations by reducing number from, let's say, 1,000 to 1,000 to 100 to whatever. We degrade all the way to we no longer can shrink it. So now we're out of the inner while loop, and now we're at the point of checking whether the sum of squares is equal to 1 or 0 or not. So if at the last stage the sum of squares, which is kind of similar to this case in the example, is going to be 1, we return true. Else, what do? Well, we update the number to be sum of squares. So if the sum of squares was 1, we return true. If it's not, we update the number to be the sum of squares, right? Let's say we're here. Let's say we're at somewhere here in the example. The sum of squares is not equal to 1, right? So we're going to update the number to be 68, and then do the while loop again. So under a few conditions, this code will return false, which is, or the scenario actually, is that we keep entering this if statement, else statement, and then we keep trying adding the number to the loop set. However, we no longer can add it. So we loop out of that while loop, in which case we're going to return false. Okay, so what did we do? We first used the hash set to record the sum of every digit square of every number occurred, and once the current sum can't be added to the set, we return false. And when the current sum equals 1, we return true. So in HashStat and in HashMap, Java first use object's hashcode function to compute the slot for the key. And if those two keys have the same hash code, this is called a hash collision, and it's rare that occurs. They will be compared by using second keys equals method. So if returns true, the two keys exactly the same, the key will not be added, or its value will be overwritten. So if returns false, Java will create a linear chain in the slot to store both of them. So, but this is a just a side note, just for your information. So we did use the hash set. We recorded the sum of every digit square, and once the current sum, which is this one, can't be added to the set, we returned false. Now, if the sum of squares was equal to 1, we return true. Okay, so I hope that was helpful. So as we wrap up this session, my greatest tip for acing those technical interviews is do a lot of questions. It's a cliche, but it's a really, really fundamental thing. And but doing just a lot of questions it can be very, very tiresome and repeated process. And you want to really be able to find efficient questions and efficient solutions rather than doing just 1,000. And it's better to do 100 good questions than doing 1,000 random questions. So this is what I do at HiCounselor, which is doing these technical questions that I actually faced in these Google, Amazon, Microsoft interviews, and doing this with you one by one. So if you're looking for technical mentorship, going through the coding questions together, or just coaching in how to get into big tech companies through networking, recruiter, and interviews, make sure you go to HiCounselor.com and use the referral code Andrew. That's going to be HiCounselor.com, which is here, and then use the referral code Andrew, ANDREW. It's absolutely free. You pay 0 upfront. Absolutely free. You pay 0 upfront, and then you only pay when you get the job. So yeah, go to HiCounselor.com, use your referral code Andrew, ANDREW. Thank you so much, everybody, and I'll see you in the next session.